title for my talk is The Fourth Industrial Revolution and Climate Change. Climate change is a very hot topic these days. I want to showcase today how we can use the techniques and technologies from fourth IR to deal with both adaptation and mitigation of climate change. So that's the objective. So going forward, let me move on. So we are going to talk about, first of all, briefly, talk about IEEE. And IEEE, many of you are members, so I don't need to say much about it. But what is I see as the fourth industrial revolution that is coming upon us? What is fourth IR? Fourth IR is automation of traditional manufacturing and industrial processes using modern smart technology. Modern smart technology. That's including machine-to-machine learning, communication, IoT, and self-monitoring. That's going on. Then the question is, how can we use fourth IR for sustainable development through technology? For example, we have talked about, you know about this, advanced computing, robotics, chip manufacturing, energy production and delivery systems, telemedicine, electrification. So how is that set of activities going to help us? Well, what role can IEEE play in this? IEEE, as many of you know, has 39 societies and 7 councils, members 410,000, including almost 3,000 or so in Bangladesh. So what is their role? Let's talk about that. IEEE covers aerospace, AI, biomedical, computing, consumer electronics, energy, history of technology, robotics, semiconductors, sensors, telecom, and transportation. So what is then, with all that background knowledge and history and practice for these areas from aerospace to global telecom, can do that. So what IEEE is doing, that's why I'm now in Egypt. I'm calling you from Sharm el-Sheikh, which is the site of COP27 in this year, 2022. So here we are showcasing how technology can help in promoting climate change mitigation. So we are facing an unprecedented level of awareness of climate change among students, faculty, industry engineers, government, everybody. So there's a big problem. I'm a power person, power engineer. I want to focus my few minutes in the area of electric energy related emissions. Electricity sector contributes 30% of the global emission today. But there's a problem. Countries like Bangladesh, India, Vietnam, China, and so on, Indonesia, are still using fossil fuel. They'll continue using fossil fuel next 30 years or so. That's one group. Other group led by US, UK, Germany, and so on, they're reducing their fossil fuel consumption and asking these developing nations to control their emission, but not by not burning coal. That is difficult for countries like Bangladesh. The coal is a ready fuel. It is not as expensive as nuclear in many cases. So they're saying we need to burn coal because we have no other alternative. That's the friction. So I am proposing a middle ground, I call it third way, deal with this. Nobody's blaming each other, but everybody is doing their part. So I have promoted a 6-point approach to reduce carbon emission, and that has been published in the IEEE Spectrum September issue. What are the 6 points to reduce carbon emissions? One is use less electricity, higher energy efficiency. If you use less electricity to do the same job, same cooling, heating, and lighting, you're burning less coal. Very simple. This is low-hanging fruit for reducing carbon emissions, number one. Number two, if you have to use fossil fuel, use low-carbon fossil fuel. As you know, coal is the most polluting among the three fossil fuels, coal, oil, and gas. Coal is the highest, oil is in between, gas is less polluting in terms of carbon emissions. So that's their proposal, is using low-carbon fuel. Bangladesh is doing quite a bit. Bangladesh's major generation source is right now gas. That's number two, low-carbon fuel. Number three, use hydrogen and other storage technologies to take advantage of excess capacity for solar and wind, not just Bangladesh, other countries, store that for later use, number three. Number four, promote more renewables. That means more solar, more hydro, more wind. Bangladesh doesn't have much wind. Solar is a possibility. That's possible. Then, since not every country can be self-sufficient in renewables, so we would encourage what you call cross-border power transfer. Cross-border power transfer. That means you have, like Bangladesh, Nepal has excess hydro. So rather than Bangladesh trying to build a lot of solar without land capacity, look at approaching Nepal to sell excess hydropower into Bangladesh. That's what we call cross-border power transfer. The another term I use, no transition without transmission. You cannot transit from coal, oil to all nuclear, all non-fossil without transmitting across. That's number five. Number six, accept some nuclear. Nuclear is not totally available everywhere, but we have to look at that. So first of all, energy efficiency, my research shows if you use light intensity from 100 to 80%, you'll save 10% energy. If you raise your temperature by 2 degrees C for air conditioning, you save over 15%. Those are not difficult to deal with. So those are things we have to talk about. Next is I talk about highly efficient fossil fuel power plants. Examples. One is Bangladesh has many of these. Combined cycle gas steam power plant. You have a gas turbine. The exhaust from the gas turbine will be used to preheat the water into steam, and that runs the steam turbine. That's common technology. Typical coal-fired power plant can give you 43, 44% efficiency. Combined cycle gives you 56% efficiency. That's a big deal. And then next is ultra supercritical steam power plant. That means high temperature, critical steam power plant, supercritical. It's happening in Bangladesh. Rampal is going to be supercritical steam power plant. So those are the examples, and this is not theory. There are plants running in the world. I know one example in the Netherlands where the supercritical power plant gives 46.2% efficiency. So that's fine. Finally, it's not there in Bangladesh yet. If you have to burn coal, if you have to burn oil, producing CO2, what do? One way to get out of this, it's expensive, called carbon capture and storage. You capture the carbon dioxide, leaving the chimney or through the chimney, through chemical processes, and store that somewhere. That's happening. Next, we talked about renewable energy. We all know about this, but the challenge is if you are using large percentage of renewable in your grid, you have some stability problem that we need to look at. So globally, then question comes up, who has the most renewables? As of 2 years ago, China had about 800,000 megawatts or 800 gigawatts of solar, wind, and hydro. China number one. Next is US, about 300 gigawatts, then Brazil, Germany, and so on. That's the country breakdown. Question then is, how is the wind, solar, hydro mix working out today? Roughly 50% is hydropower globally among renewables. 24% is onshore wind. About 21% is solar photovoltaic. So half hydro, 24% wind, and 21% PV. So hydrogen is not commercially available yet, but a lot of work is going on. The large storage batteries like lithium ion batteries quite well. Zinc oxide batteries are being used. Flow batteries are being used. That's happening. So next is cross-border power transfer. We said no transition without transmission. So we have to look at possibilities. Globally, most countries depend on other neighbors for excess capacity. US buys a lot of electricity from Canada, hydropower, lot. France sells nuclear power to Italy, Switzerland, and Spain to some extent. So this is nothing new. We have to use that as one of the 6 items in our portfolio to deal with the climate change problem. Finally, the advanced nuclear technologies, we call them SMR, small modular reactors. They are not as big as Gurukul 1200 megawatt. They're like 60 megawatt, 100 megawatt. They're safer, smaller, and the best thing is you don't have to build a 2000 megawatt plant over in one location. 60 megawatt, 100 megawatt, spread them around, needing less transmission loading. These are reactors, but the summary is, what's the bottom line? Bottom line meaning, fine. We in the electric power sector are doing all these things I just talked about, reducing carbon. Globally today, carbon emission coming from 2 big sources. One, power, other transportation, and number 3, industry. So if we, in the power business, continue reducing carbon emissions by doing all the stuff I talked about, however, you're buying more cars, more diesel trucks, keep on raising the consumption of fossil fuel in the transportation sector and causing carbon emissions. So this is the problem. We cannot solve the problem by ourselves. Others have to look into this as well. 2 other big sources of CO sources are cement manufacturing and steel making. Now there's a term called green steel. What is green steel? That's typically the furnace that is where you burn the coal is replaced with electric induction heating. So my summary is, yes, we will do the best we can in power sector, try to electrify cars, electric vehicles. However, if the electricity for the electric car comes from a coal-fired power plant, it didn't do much good. So be careful when it's to talk about EV. At the same time, ask that question, where's the power to run the EV coming from? So with that, I have to stop here. My time is up. So if you have any questions, you can look at my website. My website is srahman, SRAHMAN.org. So that, thank you very much for your attention. I apologize, I could not show my slides because of the internet at the hotel in Egypt, but I'm here. So if I'm okay for the next few minutes. So Celia and Fatah, if there is a time for question, let me know. Otherwise, I'll hang up now. Thank you very much.
Thank you, sir, for putting so much effort to reaching out to us. এখানে স্যার আমাদের নিউক্লিয়ার পাওয়ার এক্সপার্ট, আমাদের পিলার, তারপর আমাদের বঙ্গবন্ধু স্যাটেলাইটের পিলার শাহজাহান স্যার আপনি মনে হয় চেনেন, এবং আমাদের বিসিএসআই এর চেয়ারম্যান ডক্টর আখতারউদ্দিন ওনারা আছেন, এবং একটু পরে পিডিবির চেয়ারম্যান স্যার চলে আসবেন স্যার। তো আমি আসলে এই আমার বিজ্ঞ প্যানেলিস্টদেরকে বলতে চাই, স্যার আপনাদের কি কোনো বেসিক কোশ্চেন আছে স্যারের কাছে?
My name is Akhtar. I'm from Chairman BCSS. Sir, I heard you talk in Rise Buet. So yeah, it's a nice talk. It is contemporary. You see, the 4th industrial revolution and energy is very much related with each other. So thank you, sir, for your presentation, and I'm very pleased to be here in the conference. Thank you.
Thank you, sir. Thanks for your comments. Thank you.
স্যার ওই যে পিডিবি চেয়ারম্যান স্যার মাহবুবুর রহমান স্যার চলে এসেছেন। আমি বলছি স্যার এখানে আছেন। স্যার আমাদের সাথে অনলাইনে কানেক্টেড আছেন সারা ওয়ার্ল্ডের IEE প্রেসিডেন্ট জানুয়ারি 8 থেকে প্রফেসর সাইফুর রহমান। He was past president of Power and Energy Society. So if you have any general question, as he is a world-renowned power and energy expert, and you are leading the top generation organization of this country and doing wonder. You can ask some basic question if you want. It is a way of interacting with him. He is there.
বিদেশিরা আছে বাংলা ইংলিশে বলবো না বাংলায় আচ্ছা আসসালামু আলাইকুম
ওয়ালাইকুম আসসালাম।
জি, আমি ইঞ্জিনিয়ার এমডি মাহবুবুর রহমান, বর্তমানে চেয়ারম্যান বাংলাদেশ বিদ্যুৎ উন্নয়ন বোর্ডে কর্মরত আছি। আমরা রিসেন্ট তো আমাদের একটা ন্যাশনাল গ্রিড পার্শিয়ালি ফেলিউর হয়েছিল এবং মিনিমাম টাইমের ভিতরে আমরা এটাকে রেস্টোর করতে পেরেছি। তো সেখানে অনেকগুলি কম্বিনেশনের ইফেক্ট হিসাবে এই গ্রিড ফেলিউরের কথাটাই বলা হয়েছে, কমিটিতে আসছে। তো এখানে যে বিষয়টা আসছে যে এফজিএমওর কথাটা আসছে, স্পিনিং রিজার্ভের কথা আসছে। তো একটা বিষয় একটু জানার জন্য, সেটা হলো যে আমরা এফজিএমও হিসাবে আমাদের 28টা পাওয়ার প্ল্যান্ট এখন এফজিএমওতে আছে, কিন্তু ফুয়েলের ক্রাইসিসের কারণে প্রত্যেকটা প্ল্যান্টকে ফুল লোডে চালানো যাচ্ছে না, পার্শিয়াল লোডে আমরা চালাতে হয়, যার ফলে এফজিএমও থেকে যে স্পিনিং রিজার্ভ যেটা রাখতে হয়, যেটা পরবর্তীতে ফ্রিকোয়েন্সি ফ্লাকচুয়েট হলে জেনারেশন দিয়ে মেকআপ অ্যাডজাস্ট করা হবে, সেটা করা সেদিন যায়নি এবং এই সমস্যাটা আমাদের রয়ে গেছে। এখন যে বিষয়টা একটু জানার জন্য, যে আমাদের সিস্টেম সম্পর্কে আপনার তো ভালো ধারণা আছে, আপনি কাজও করেছেন, জানেন স্পিনিং রিজার্ভ আমাদের কতটুকু থাকা উচিত বলে মনে হয়। আমরা ইচ্ছা করলে খুব বড় ধরনের স্পিনিং রিজার্ভ রাখতেও পারবো না, কারণ আমাদের জেনারেশন শর্টেজও আছে। একটু কাইন্ডলি যদি বলেন কি মনে হয় কত পার্সেন্ট হলে এই সিস্টেম এটা অ্যাকোমোডেট করতে পারবে?
Very good question. Assalamu alaikum. Our experience working in the US, এখানে রাখে রিজার্ভ about 10%, স্পিনিং রিজার্ভ 10%। তো ওইটা একটা ফিক্সড নাম্বার নয়, তার কারণ ডিপেন্ড করে কি মিক্স আপনার কি আছে সিস্টেমে। If you have mostly synchronous, which was the case some years back, তখন you can do less because you have to be ready. We say n-1. The biggest unit can fail or biggest transmission line can fail. Make enough reserve in all the other remaining power plants so that they can pick up that difference. That's the philosophy. What's happening in the US, mainly Europe now, and China as well, because of heavy solar penetration, solar has no spinning reserve by definition. But you can control the P and Q of your EE, power and reactive power, to control some output. To answer your question directly, that's ideal 10%, but do the best you can. The problem, I have been to your load dispatch center. I mean, I'm so okhane there's no AGC, no automatic generation control. If you have no AGC, spinning reserve doesn't do you much good because you have to call the power station to raise the power and so on. So my answer is 10% target, maybe 5%, depending on your mix at the time. And other problem Bangladesh had, I studied extensively the 2015 blackout nationwide. Tokhon you had about 1,000 megawatt in small diesel plants. So they have no spinning reserve. So it's not a simple answer. A lot of things have to work in conjunction. So target is 10%, do the best you can, and bring as many units as you can under automatic generation control. Hope that makes sense.
Thank you, sir.
Dr. Saifur, would you say something? No? Okay, thank you, sir.
Okay, thank you.
My name is Hussein Mansoor, Professor of Geology. Sir, one thing I want to ask you, that you have already discussed some problem of emission of carbon in our planet. So this is the question that you are burning some fossil fuel and increasing the consumption of carbon in our atmosphere. So this is the cause of the warming of our global climate. This is the case, that there are some evidence that the global climate is changing and our planet is warming up. So this is the normal case.
Sir, I think you know that the climate of our planet is changing in a cyclic way. Long-term cycle, intermediate-term cycle, and short-term cycle. And there are some micro cycles in our geological history. So our planet is just warming up, and solar radiation, the variation of solar radiation is the cause of the change of climate of our planet. Sir, you know that, I think, of course you know it. So there are some cycles 375 million years, there are some cycles 100 million years, and there are some cycles 100,000 million years, and so on. And this is the case, that is a regular phenomena that's happening at the birth of our planet. Sir, I am telling some details that you are just, you have some problem of emission of carbon. And yes, of course, the emission of carbon due to the burning of fossil fuel is warming up, because the ice on the continent are melting, and meltwater is discharging into the ocean basin. So this is the case that we have, we can see. But there are some evidence that there are some microcycles. Microcycles means so sea level is very much related to the warming of our planet, because during the cold period, the water accumulates on the continent, and during the warm period, the ice melts, and meltwater returns into the ocean basin, and sea level rises. So about 18,000 years before, the sea level was about 130 to 140 meters below the present sea level. But during the history of the 10,000 years, there are some minor climatic cycles also. And about 5,500 years before, just from the before, we have some evidence that I have lot of data, and I have lot of field experience and carbon dating through that Dhaka and the surrounding areas were inundated with brackish water. There's the saline water about 5,500 years before, because lot of evidences, and I have lot of researches that there are some pollen growth, that the mangroves were growing, say, in and around Dhaka city. So it means that 5,500 years before, sea level was higher than the present sea level. And there's no evidences of emission of carbon about 5,000 years before. So would you kindly, do we have any findings that the sea level, there's a warming up of our global climate about 5,000 years before, and the global climate is warming just today? Is there any difference between the global climate of 5,500 years before and the global climate of today? How much relative to the warming up of 5,500 years before, and the at the level of the present day warming up? Do you have some data or some measure of this kind of things? And I think there are some other problem of our government too, that we are just will very soon will open our coal-fired power plant in the southern area, and the emission of carbon that we are just burning the fossil fuel is mass less than the emission of carbon what they are burning in China, India, Australia, and etc. Specific. So now that question you probably apne, I mean, just both. I don't know whether you understood my point or not. The
I have.
global climate.
I have, understand.
Did-
Let me
did- do you-
answer, yeah.
Please,
Hold on,
sir,
let
sir,
me answer your question.
Don't mind,
Let me
just
answer.
I'm asking you.
Okay, let me answer your questions. The first question you raised about the data for carbon and temperature. The data for carbon concentration in atmosphere is available going back 800,000 years. The data from NASA and other, I can give you the source. That's one question. The data for temperature is no more than 200 years old. We did not know how to measure temperature 1,000 years ago. We had no idea. If I follow that track, I gave a talk on this very topic in Singapore last week. I can give you the link for those slides. The answer is CO2 concentration had been in the 100 parts per million range for last 800,000 years, 100 to 120 ppm, CO2, not temperature. Beginning the late or early mid 1700s, when the steam engine came to place, that we call the steam revolution, the third IR, we began to see higher level of CO2 concentration. Even then, that was in the range of 300 or so. If I go back to 1950 data, we see the level of CO2 concentration rising steadily up to about 430 ppm today, 430 ppm. Temperature, you're right, fluctuates, goes up and down, But if you look the trend, long-term temperature rise, there are annual variations, which is true. But if you look at the slope, is positively rising. It's about 1.2 degrees more than what it was in the mid to late 1700s at the start of this steam engine. So that's the data. So answer is sea level rise. We don't have data that far back because we did not measure what was the sea level in Bay of Bengal in year 900. We have no idea what that was. But we know overall rise is happening. So the question is, those are facts. We cannot change history. My focus is what can we do? That is why I'm now in Sharm el Sheikh, Egypt, speaking at the COP27 on this very topic. So what we have to do as engineers, most of you are engineers here, is what is our role? Regardless of what happens globally, you're right, China is emitting 100 times more CO2 than Bangladesh does. But if we keep on blaming each other, we don't go anywhere. Keep blaming all day, it doesn't matter, it doesn't help anything. So I want to be a responsible citizen in Bangladesh, do our part, and set the target and the example for the world. Bangladesh is taking steps through energy efficiency, reducing coal usage, using cross-border power transfer, using nuclear, and using as much solar as possible, given the country's size and population and the land usage. So those are the positive things I want to focus so that we can be an example country, example citizen, an example community of technologists who are challenging the problem and giving some solutions. That would be my approach. Hope that makes sense. Thank you, sir.
Thank you very much, sir. I'm very happy that, sir. Sir, thank you very much, sir. Sir, one thing that when we got our independence after under the leadership of our great father of nation, Bangladesh Sheikh Mujibur Rahman, we entered into the third industrial revolution. So we are just as a growing nation, just we got our independence, and Bangabandhu ruled the country not more than 3.5 years. So we could not participate in the third industrial revolution. So now we are at the time of her daughter, Sheikh Hasina. He's now running the country, and we are just entering into the fourth industrial revolution. So one era finished by our father of nation, and next era started with his daughter Sheikh Hasina, just in the fourth industrial revolution. So our new generation, we want most knowledge-based society and scientific society, and we want to improve our technology and its application. And I hope this seminar will be beneficial to us to make our new generation a ideal citizen, an ideal citizen for Bangladesh. Thank you, sir. Sir, you have already attended to our seminar some 1 or 2 years before, and we are very happy that in December, sir, we are very happy that since you could manage your valuable time traveling abroad and join to our seminar. Sir, we are very grateful, and we will have some more advices from you. You are the most what is called the eminent and proud nation of Bangladesh, a proud citizen of Bangladesh. That you are the ambassador of Bangladesh. You are representing Bangladesh in the scientific forum. Thank you, sir. Always we will take help from you, and will ask and request some advices from you. Thank you, sir. Our audience is full with dignitaries from all important departments of Bangladesh. Thank you, sir. Very much. Thank you.
Thank you. Thank you. Assalamu alaikum.
Sir, would you like to say something to our audience?
No, একটা only comment হচ্ছে যে আমি খুব প্লিজড, সন্তুষ্ট যে আপনারা এত সবাই এসছেন। দেখলাম স্বাধীন ভাইকে দেখলাম ওখানে স্ক্রিনে, সবাই এসছেন এবং সবাই শুনছেন উৎসাহ নিয়ে জিনিসটা। এবং আই হোপ এটা আজকেই শেষ হয়ে যাবে আলোচনাটা। এটা আলোচনার সূত্রপাত হলো, আপনারা আলোচনা করেন among the industry colleagues, policy makers, sector corporation chairman, politicians, faculty members, professors, যে আলোচনা যেন অব্যাহত থাকে, এটা আমার একমাত্র রিকোয়েস্ট। আপনার আলোচনাটা চালিয়ে যান আর কি, and I'll be happy to contribute. Thank you very much.
Thank you, sir.
Okay, thank you. Bye bye.